Greetings to everyone. This is Hari Prasad, currently working as assistant professor in the Department of Electrical and Electronics Engineering. And today we will have a look into the introduction of drives. So first of all, what is a drive? So we all know that a system that is employed for motion control is a drive. So we will proceed in that format. The best example for this is you can consider a pulley system. You can consider a pulley system by which you are fetching water from a well. Now this pulley system, it can be hand operated by using a rope system. So this is an ancient practice. Nowadays you will not find this system in a majority portion because you have got the support from electrical domain. So the basic example is a pulley system or even any wedge system which is used in the earlier days, which was used only for a motion control purpose. You will call it as a drive. Now if I am incorporating this drive with the help of an electrical motor. So the other modern example is driving a rickshaw. I am driving a rickshaw. So this is, I have to pedal it. Now if I am incorporating a motor, you call it as auto rickshaw or motor rickshaw. So the person who is driving the rickshaw can use the help of a motor and he can drive the rickshaw. So if I am utilizing this motor, the speed control of the rickshaw will depend on the motor. The speed control will depend only on the motor instead of the person driving the rickshaw. So it will not depend this one, it will depend only on this motor segment. So those segments are called as electrical drives. Now we will enter into the classification domain. The basic classification, it is AC drive and DC drive. So it is brought up only with the help of supply system. This classification is based on supply. So you can classify either as AC drive or DC drive. Now further, the recent classification is, you can classify this into individual drive. You can classify this as individual drive. You can classify this as group drive. Further, you can classify this as multi-motor drive. So this is the classification brought up based on the application. This is based on the application. Now individual drive, you will have one motor for one purpose, which means one application. Now group drive, you will have one motor which will serve many applications or many purposes. In multi-motor drive, you will have one motor for one application, but it is going to have more number of individual segments which is grouped together called as multi-motor drive. So the example is tower crane. So when you find that you have a tower crane, imagine that the segment is like this, a horizontal arrangement where you can have this arrangement for lifting tools and other mechanism. This is on the ground system. So you have one drive segment which is for this vertical movement. So this is a drive segment, which means a motor is here which is going to help for the vertical movement, whereas the other segment you will have a motor set up here. So what will happen is, this is for the horizontal movement. So multi-motor drive, you can have too much of drive systems incorporated into a single system, but you will have various applications coming out of it. Okay, now we will understand how we are selecting this drive. So there are some factors that are actually determining this selection. The first one is steady state operation requirement. So steady state characteristics, we will focus on that, which means the speed and torque, because those are not going to be transient oriented. They are basically steady state operation points, and speed fluctuation is there. Speed can fluctuate while operating a drive. Speed can be regulated based on the need. Speed range is there, you can operate from 0 to maximum, and you can calculate the efficiency. So these are the operation requirements that will be focused on steady state. And moving into the transient, so transient meaning is sudden change. Meaning of transient is sudden change. So the sudden change requirements, what are the parameters that we will focus is, the first one is a machine which is operating, it can be accelerated furthermore, or it can be decelerated from the normal acceleration. So we will have the value of acceleration and deceleration. So acceleration, it will focus on starting, whereas deceleration will focus on braking. Then the next one is the requirement related to source. So coming with the previous slide, we have just classified this into AC drive and DC drive. It is based on the supply. So if I am giving an AC supply, if this is fed to a motor, so AC supply default it is going to be only AC motor. Then if it is going to be a load, so this is the basic example of a drive system which is operating under AC conditions. Similarly, if I am feeding DC supply, I will have a DC motor. So with this respective parameter, it will depend on the type of source. So it can be either DC or AC, because AC is commonly available. If it is in need of DC, we have to go for further modifications with the supply. Then the second one is power factor. So we have got some values within which the power factor should lie within. Then harmonics, it is focusing like disturbances. So harmonics has to be considered. Then magnitude of voltage. So normally if it is 220 volt or 230 volt, should understand the magnitude value. What is the value that we are operating? So these are some of the basic parameters that we have to focus. And apart from that, the establishment parameters, capital and running cost. So what is the cost that I am investing? Capital cost, it is the investment cost. Running cost is during the operation, so it is the operational cost. So how much I am going to invest and how much I am going to get it as reward. So capital and running cost. Then maintenance need. So how much I am going to impart for maintenance. So it is whether it is going to be a daily maintenance or weekly maintenance or annual maintenance. So this can be either monthly or yearly depending on the drive system. So maintenance needs that we have to also consider. Then the next one is space and weight restriction. So how much is the space that I have got in the factory, space availability. So how much drives I can install, how much machineries I can keep there. Weight restriction, whether if I am going to install it in the ground floor or if this can be kept in the first floor, or any foundation requirements are there. So those parameters has to be considered. So we will focus on weight restriction, because if you are taking the best example as tower crane, it has to be kept or it has to be provided a foundation only in the ground floor. So similar way, you have to focus on weight restrictions. The next important thing is the environment, whether it is going to be radioactive environment or explosive environment. So I have to focus on the environmental needs. Why we are considering this parameter to be as one of the most important parameter is, if I am using a drive system, if I am using an AC motor, if this is kept inside an coal mine, any spark from this motor can ignite the entire segment. So you have to be very conscious in analyzing which type of motor has to be kept in that particular location. So location, again, it is hot environment, cold environment, dust environment. Because dust environment, the example is flour mill. So you have to ensure that the dust should not accumulate inside the motor and it should not disturb the efficiency of the motor, and in similar way the dust accumulation on the motor will reduce all the major efficient parameters. And the next one is reliability. So this is nothing but the life cycle or lifetime of a machinery. So because there is a separate topic called as reliability engineering. So this will mainly focus on the life cycle of the equipment. So initially where the efficiency will be at a higher point. So initially when you are purchasing a new equipment, your efficiency will be at the higher point, whereas it gradually comes down. So you can understand from the reliability curves, and at the same time when you are checking this efficiency, if you are coming with the cost, the initial cost may be at a nominal value, but if the maintenance is kept low, this cost will keep running at a higher stake. So this curve will be normally called as bathtub curve. This comes under reliability engineering as an introductory part. So the major thing is this reliability is actually depending on the maintenance. So summing up, we will have 7 parameters. One is steady state operation requirement, the second one is transient, third one is requirements related to source, fourth one is the capital and running cost, then maintenance need, then you have got space and weight restrictions. So how much I am going to have the space and how much is the weight that I am going to incorporate. Environment location, how far I am going to utilize the environment. Then reliability is going to be the life of the machinery. So few applications, they are majorly used in paper mill, steel mill. Then you can even go for traction systems, the modern day railway traction system. So all these are some of the applications. Thank you.